In this tutorial, we'll be discussing selected problems from your homework biconditional statements. On the first set of problems, you're given the conditional statement and you're asked to write the converse and biconditional statement. So the first conditional statement reads, if 2x plus 5 equals 11, then x equals 3. So the converse of that statement would read, if x equals 3, then 2x plus 5 equals 11. Now, before we go any further, let's discuss the validity of each one of these statements. If 2x plus 5 equals 11, then x must be 3. Is that true in every situation, no matter what it is? Yes, it would be true, because 2 times 3 is 6, and 6 plus 5 is 11. So yes, that's a true statement. Now the converse. If x equals 3, then 2x plus 5 equals 11. Again, that's still true because 2 times 3 would be 6, plus 5 is still 11. So since both the conditional and the converse are true, then we can write a conditional statement. We can write a biconditional statement. And the biconditional statement would read 2x plus 5 equals 11 if and only if x equals 3. On problem 3, they provide us with the biconditional statement. We have to break it apart and determine the conditional and the converse statement. So the biconditional statement reads, an angle is a right angle if and only if its measure is 90 degrees. So if we recall from class today that the hypothesis is going to be everything in front of the word if. So right here, an angle is a right angle will be the hypothesis, or P. And then everything after the last if will be your conclusion. So the conclusion is its measure is 90 degrees. So when we write the conditional statement, we write it as if P, then Q. So it would read, if an angle is a right angle, then its measure is 90 degrees. And there should be a little degree symbol here. We can fix that right now. And then that means the converse, again, is simply when you switch the hypothesis and the conclusion. So the converse would read, if an angle measures 90 degrees, then it is a right angle. And there's my degree symbol again. Now let's determine the validity of each one of these statements. If an angle is a right angle, then its measure is 90 degrees. Yes, that's true. If an angle measures 90 degrees, then it is right angle. Yes, that is also true. So since both the conditional and the converse are true, then your biconditional is a true statement. It is a valid statement. Number 5 wants us to determine if each biconditional is true, and if it's false, give a counterexample. So number 5 says, Felipe is a swimmer if and only if he is an athlete. Well, in order to determine if the biconditional is true, I need to break it apart and find the conditional and the converse. So let's establish what the hypothesis would be. So the hypothesis is Felipe is a swimmer. The conclusion would be he is an athlete. So if I was writing the conditional statement, sorry, it could say if Felipe is a swimmer, excuse my handwriting, then he is an athlete. So that would be the conditional. If Felipe is a swimmer, then he is an athlete. So now the converse would be if he is an athlete, or if Felipe is an athlete, then he is then he is a swimmer. Now let's determine the validity of both the conditional and the converse. So the conditional, if Felipe is a swimmer, then he is an athlete. I agree. Swimmers are athletes. So that is true. On the converse, if Felipe is an athlete, then he is a swimmer. Is that true all the time? No. It's only true some of the time. So the converse is false. Just because he's an athlete does not mean he swims. He could run track, he could play football. There's other types of athletes out there. So since both the conditional and the converse are not true, then we would say the biconditional is false as well. And it's false again because you don't have to be a swimmer to be an athlete. You can play other sports or do gymnastics, golf, and things of that nature, and you're still an athlete. Number 7 through 11 are multiple choice questions. However, you just need to make sure you're reading the question very carefully because I can guarantee you'll see problems like this on your upcoming tests. So number 7 reads, which conditional statement below can be written as a true biconditional? Which statement below could be written as a true biconditional? Well, let's see. If a coin is a dime, then it is worth less than 25 cents. So that is true. Now let's see if the converse would be true. If it is worth less than 25 cents, then the coin is a dime. That's not necessarily true because you could have pennies, you could have nickels. They're all less than 25 cents. B, if a vehicle is a car, then it has four wheels. That's a true statement, but let's check the converse. If it has four wheels, then it is a vehicle. Then the vehicle is a car. That seems to be true to me. So let's go ahead and mark that just to be sure. And we'll double check in a moment. C, if a number is greater than 0, then it is a positive number. That's true. Now read the converse. If a number if a number is a positive number, then it is greater than 0. That is true. So that would be a true biconditional as well. So let me go back and read the first one. Maybe I wasn't thinking clearly. Let me see. Okay. If a coin is a dime, then it is worth less than 25 cents. All right, now the converse. If a coin is worth less than 25 cents, then the coin is a dime. Nope, it's still not necessarily true all the time. Like I said before, it could be a penny, it could be a nickel. Now let me read B again. If a vehicle is a car, then it has 4 wheels. That's true. The converse would read, if a vehicle has 4 wheels, then the vehicle is a car, or then it is a car. Can you think of other 4-wheel vehicles that are not cars? Um, I definitely know C is for sure, and true no matter what. So let's just say our answer is C to be on the safe side because we definitely know it's not all the above because A is not included. B could be wishy-washy because there are some other vehicles out there, but even though the most common vehicle with 4 wheels we can think of is a car, there's a lot of engineers and out there who are creating different mobiles that can do some other things. Like a skateboard. A skateboard also has 4 wheels. So that would be, I guess, considered a vehicle. So the answer is C. Number 9. What is the inverse of the statement, all geometry students are in 10th grade? The inverse. A. If you are in 10th grade, then you are a geometry student. If you are not in 10th grade, then you are not a geometry student. If you are a geometry student, then you are in 10th grade. And D. If you are not a geometry student, then you are not in the 10th grade. So the answer to this one is D. And this concludes your tutorial on biconditional statements.